All right, so hopefully you just viewed the lesson on VSEPR theory and the introduction to VSEPR theory. And what I want to do next is to take a look at the homework that we had last night, where we already gone over the Lewis structures. And we're going to classify the VSEPR shape as well as give the bond angle for each of these. Now, before I do that, I want to just review with you the 5 VSEPR shapes that you all will be responsible for knowing. And have grouped these according to what I call their cousins, if you will. So the first one, the X here represents my central atom. So you can have, if you have your central atom with 2 atoms attached to it, you can either have lone pairs also on the central atom, like you see in the second example, or no lone pairs. If there are no lone pairs, we call it linear, and the bond angle is 180 degrees around your central atom. So that's around here. Now this is, again, once you draw your Lewis structure, so you would have made sure that the octet rule is satisfied for each atom present. Here, if you see lone pairs on the central atom, remember those lone pairs bend the molecule, and so it's either called bent or angular, and the bond angle there is 105 degrees. Now the next 2 VSEPR shapes that I call cousins involve your central atom having 3 atoms attached to it. So the X here is my central atom again. It has 3 atoms attached to it. Notice in the first example here you see there are no lone pairs on the central atom. In the second example you see those lone pairs again. So if there are no lone pairs, even though on your paper your Lewis structure would look sort of like what I have here, and I don't expect y'all to redraw it so that it looks to scale, but I do want you to be able to look at it and then predict what it should look like geometrically. So here, since you have 3 atoms attached to the middle, we call it trigonal, and that's, think of a triangle. And it's going to be a flat molecule, so it's planar. Bond angle is 120 degrees. Now, if you play with the PhET simulations that I attached to Edmodo, you can kind of turn the molecule around and see the 3-dimensionality of it, and you'll see that it's very flat, it's planar. If you add lone pairs to the mix, it's going to bend the molecule or bend those bonds downward. So that's where you get the pyramid shape, trigonal still, because there's 3 atoms attached to the central atom, but it's pyramidal, like a little pyramid. So it's actually going to sit up, so sort of like this. Those lone pairs are going to push those bonds down, and you have the lone pairs sitting up top here. The lone pairs take up a lot more room, so they're going to push the bond angles down, so it's 107 degrees. Finally, the last shape that you guys need to know for chemistry 1 anyway is tetrahedral. Now this one looks like the bond angles are 90 degrees, but remember they spread out farther than that. And again, if you play with the PhET simulations, this will be more visually understandable. But the bond angles are 109.5 degrees. So let's take a look at those homework examples and classify our VSEPR shapes. So here we go. So as I look at the first example here, I see that the sulfur is my central atom. Notice he has 2 atoms attached to him, and he has lone pairs here. Now, if you have 2 atoms attached to the central atom, it's going to either be linear or bent. Now, recall that the lone pairs actually bend those little bonds down, so we're going to call this one bent, or if you prefer, you can call it angular, and you need to memorize the bond angle that corresponds to that. All bent molecules are understood to have a bond angle of 105 degrees. All right, for the next one. Now, this one does not have a central atom. Remember I said in class that the only way to attach 2 points, since there's not a central atom, there's no vertex, if you will, is in a straight line, so you would just call this linear. And of course, that's 180 degrees for all linear. 180 degrees is straight across. All right. Number 3, if you look at the carbon, there are 4 fluorines attached. So the only VSEPR shape we have that we have to understand, or we have to know at this level of chemistry, is tetrahedral for the 4 atoms attached. Remember, the tetrahedral shape is going to be 109.5 degrees for the bond angle all around that central atom. On the next one, you have diatomic nitrogen. Again, just like number 2, where you had diatomic chlorine, it's linear. There is no central atom here, so it's got to be linear. All right, let's look at number 5. Carbon is your central atom here. Notice he has 1, 2, 3 atoms attached to him. 1, 2, 3 atoms attached to the central atom. So it's trigonal something. Got to figure out what exactly. So when you're trying to decide whether it's trigonal planar or trigonal pyramidal, you have to understand the influence of the lone pairs. Now there are no lone pairs on the carbon. There's nothing to bend that down, those bonds downward. So it's going to be flat and planar. They're going to spread out, so it's trigonal planar. And that bond angle for trigonal planar is always 120 degrees. Now if y'all pause the video and keep going and classifying them, and then restart the video and check your final answers. All right, so for number 6, I'm going to go and continue on because my video limit is 10 minutes. So for number 6, you should say that's linear. And of course, bond angle is 180 degrees. For number 7, same thing, linear and 180 degrees. All right, number 8. Look at your central atom. Now we're gonna classify the VSEPR shape based on what's around the sulfur. We're not gonna really pay attention to anything except what's on the sulfur right now. So sulfur has 4 oxygens directly attached to him. So the VSEPR shape has to be tetrahedral, and the bond angle for all tetrahedrals is 109.5 degrees. Now, if you were to consider around the oxygen here to classify there's a separate VSEPR shape for that portion of the molecule. And if you were to look at the oxygen with respect to him, you would see oxygen has a sulfur and a hydrogen attached to him. So there's 2 atoms on the central atom, but there are also lone pairs. So that's right, that would be a bent part of the molecule. So this molecule here is more complex. This oxy acid has a tetrahedral center, but if you look at where the oxygens, the OH bonds are coming off, that's going to be bent around those. But for now, we're just going to classify what's around our central atom. All right, for number 9, hopefully you said trigonal because there's 3 atoms on it, so trigonal. And the lone pairs here are going to bend those oxygen bonds downwards, so it's going to be pyramidal. And the bond angles for trigonal pyramidal is always 107 degrees. Again, you got to memorize the corresponding bond angle. For number 10, you should have said bent or angular, 105 degrees. For number 11, we have another tetrahedral structure. And for number 12, same thing, ditto, tetrahedral. And again, bond angles for tetrahedral is 109.5 degrees. Okay, so that is our lesson and our review of the VSEPR theory.